Turn on the lights for a second. It didn't explode. What's wrong? How come it didn't explode? Inside the can, I've got hydrogen, but no oxygen. And since the flame can't pop the can the way it does the balloon, it can only get oxygen as it comes out. So I fooled you. You know, we're not going to get an explosion. That what we're going to get is essentially a candle until my hydrogen burns out. This is how you can light the end of a Bunsen burner or the end of a torch, and it doesn't blow up on you because it can only burn as it exits. We've got to get the oxygen to our material. You can see it looks like our flame is starting to dwindle a little bit as we run out of hydrogen inside the can. But basically, we've made a candle. An explosive candle, but a candle nonetheless. Now, what happened? Basically, as the hydrogen was going out the top, what was going in the bottom? Air, which contains oxygen. And eventually we get to the point where we have an explosive ratio of hydrogen to oxygen inside. We reach what's called the explosion limit, and then we blow the top off the can. So if we get oxygen in with our hydrogen, we know what's going to happen. We're going to get that rapid reaction. All right, a couple of other things here. We've just had, just recently, a holiday. Somewhere around the beginning of July. What holiday do we have? 4th of July. What's the big thing that happens on 4th of July? Fireworks. There is not a better display of chemistry on parade than the fireworks at the 4th of July. These are simply oxidation reduction reactions taking place that give us all the brilliant colors up in the sky. Well, let's do our own little mini version here. Here I have a mixture of a nitrocellulose polymer, basically smokeless powder, a little bit of magnesium, a little bit of gunpowder, and other things thrown in there. You know, basically what we're looking to do is celebrate the 4th of July. And so all we need with our combustible material here is a light. The nitrocellulose will burn. The metals that are in there, when they get excited, will excite and give us light of various colors. And so if we give this, we're going to kick down the lights. Let's give it a shot here. Our own mini 4th of July celebration. All right, there we go. Pyrotechnics on parade. Pyrotechnics on parade. Make sure that's not too hot. Here we go. Now, this one is one of the few reactions I do that actually requires some work. And I figure for this one, I'm going to need a volunteer. You willing to help me out? Okay, sure. What's your name? Abby. Come on up here, Abby. Do you want to be a chemist when you grow up? Do you want to be a chemist when you grow up? Okay, sure. That should settle that. There we go. All right. This one requires a little bit of work. But you look like you're up to it. So, what we're going to do is we're going to do another oxidation reduction reaction in here. Well, what does she need before she does anything? Gotta have safety glasses. Well, I have to have the perfect pair of safety glasses for you. There we go. Get those on, get behind your ear here so that they stay on. All right, now, what you're going to do is, we need to mix the chemicals. We're going to mix them inside these bottles here. We're going to be doing a little bit of chemistry here. All right, so what we're going to do, we're going to have to mix together some silver nitrate. This stuff here, you got to be careful. If you get it on your hands will actually turn brown, and they stay brown for like a week. So try not to get it out, okay? Sure. All right. So what you want to do is take your silver nitrate, take the top off, and carefully pour it into your bottle.
It's actually water.
just like water. There we go. Now, perfect. To that, we are going to add a little bit of ammonia solution. This stuff really stinks. But you got a dropper here. So here's your dropper. What you want to do is take that, squeeze the bulb, suck a little bit up, and squirt a little bit right into your bottle. There you go. Suck it up, squirt her in your bottle. And then if we swirl that around, we have made this ugly brown crud. We don't want that. We don't want that. So what we have to do is add a little bit more. Put that in there, in your bottle. We're going to add a little bit more and swirl it around. Swirl your bottle around and see if the brown color goes away. Just kind of swirl the bottle like that and see if it goes away. Has it gone away yet? Not yet. Put a little bit more in if it hasn't gone away yet. We got to get this stuff to go away. There you go. You're good. Now, here we go. Here's me. Hey, look at that. In my class, it takes about 20 minutes for me to explain why that stuff disappears. And so let's take and add some potassium hydroxide. We have to raise the pH with our potassium hydroxide. So what you're going to do is dump right your potassium hydroxide right into your bottle. Carefully, dump it right in. And what happens? We get that brown crud back. How do we get rid of the brown crud? More of that stuff. You're right. Okay. So this time, give it a little bit of a shot. About that. Shoot that in there. And then swirl it around.